trust letter because I asked my colleagues who speak Romanian to write me some words in Romanian. So I have 200% trust on that. Bună ziua, zi bine au venit. Îmi face plăcere să salut în numele Juniper Networks. Din păcate, romana mea nu este bună. Vă rog, permiteți-mi să mi continui prelegerea în engleză. Okay, I hope it was 90% trust. Good. My name is Uwe Richter. I'm the director of Juniper Networks for Central Eastern Europe, for the pre-sales engineering team as well as the sales team. So we are covering 13 countries in this region. I'm based in a little village close to Berlin, and I'm with Juniper for 19 years now. Good. I don't have a label yet. What I want to talk today is a little bit about artificial intelligence. And I think if a taxi driver from the airport starts to talk with you about artificial intelligence, it means something is going on. Artificial intelligence is nothing new for Juniper Networks. We've been doing that for 7 years now. And of course, now is a big hype. And let's try to demystify a little bit about artificial intelligence. What is the truth? What is hype? And what we are doing as Juniper Networks. All right? So let's go a little bit on a journey. Before I do that, today, there is what we call the Mobility Field Day. That's literally every vendor in the world who has a word to say in Wi-Fi, in mobility stuff. They're coming together, it's an organization, and a couple of times per year they have what they call the Mobility Field Day. If you are interested in Wi-Fi technology, if you're interested in mobility stuff, quite interesting. We have also a presentation slot that actually starts in 2 hours, and the sessions are recorded with some sexy announcements, what we are doing there in terms of new hardware, new features. Anyway, if you're interested, watch it out. Okay, I mentioned AI, ChatGPT, Midjourney, TensorFlow, a lot of buzzwords flying around, a lot of technologies are flying around. Yes, and we call it mist. Mist has nothing to do with the mist what you have in the morning. It used to be a company called Mist, which we as Juniper acquired some years ago, and this is the core of our enterprise strategy, and what we call AI in action, artificial intelligence in action. I think it's always a good idea to start to have a common understanding. What is artificial intelligence? A lot of people think about early science fiction, remember when the robots are coming and Starship Enterprise or whatever. So AI according to Wikipedia, and I think that's a reasonable explanation, is intelligence perceiving, synthesizing, and inferring information demonstrated by machines. As opposed to have intelligence when you have humans or if you call a monkey, another animal with a kind of intelligence. What is done with artificial intelligence are speech recognition is a good example, very long time around, computer visioning, translation between natural languages, and other things are mapping inputs from one side to another. So I think that's artificial intelligence. You may or may not agree, but I think it's a quite broad definition of the word, what artificial intelligence is doing. What is artificial intelligence doing in networking operations? I think that's also sometimes a misunderstanding. What is the difference between automation and artificial intelligence? Because there are some significant differences behind. So AI can help to automate and optimize network operations. We want to reduce, at the end of the day, the manual effort, and we want to increase the efficiency. With the increasing complexity, and I read it now, the volume of network data, of course we have a lot of data we can use as a valuable input, as a baseline in order to figure out what's going on, what's inside in the network. And what AI is doing basically in the networking is trying to figure out of this terabyte of data. I think my colleague was mentioning today 150 data points are measured from our access points, 150 parameters. So there are a huge amount of data, and as more as better. But to find out what are the patterns, what identifies the anomalies which have been missed by the human analytics. Of course, we can provide more network security because at the end of the day, and it also goes into the direction of anomalies or to identify vulnerabilities which can be, let's say, identified before they get exploited. I hope I don't disappoint you because what I simply did is I used ChatGPT and I said, tell me in 3 sentences why to use AI in networking operations. Okay, I cheated. You catched me. But you see how much, let's say, that thing can stuff, and we will use it also in the pretty near future. How many of you are running enterprise networks? Quite a large number. I know an enterprise is not an enterprise. There are a lot of different things, but in general, what we can do is we can, first of all, say what are the key objectives. I mean, there are a number of objectives when it comes to complexity. We want to reduce complexity. We want to make networks as simple as possible, and simple is not a bad word. To optimize operations, I don't know how many of you are team leaders and trying to get qualified new people. Getting new people is very difficult these days. To improve the return of investment, to prioritize specific applications. And when we talk about applications or needs, you can split it in 2 directions. The front office and the back office. Front office typically is software as a service, Microsoft 365, and these kind of infrastructure as a services, any kind of applications, devices are increasing. I don't know how many of you have ever counted how many IP addresses you're using in your home network. I think mine is close to 60, 70 in the meantime. It's really getting tough. COVID has learned us that hybrid work is something which is acceptable, right? I don't know how you see that, but a lot of people are hesitant to go back to the office. So hybrid work will become part of our life. Real-time communication. I think we have seen, at least what I have a feeling is, two things we have seen in the COVID times. First of all, the renaissance of the old fixed line telephone. Hey, yeah, there's something still working. And the other thing is a video call. How many of you have done video calls before COVID times? I think it was really limited, but now it's an accepted thing of way of communication. Collaboration tools. This kind of stuff as an example. And on the back office, of course, you have things which are basically enabling your office. Video analytics, surveillance for security reasons. IoT sensors. I mean, I don't know how many IoT sensors we may have in this office here, in this building. Heating, ventilation, air conditioning. Smart inventory, all that stuff basically increases the amount of devices what we see in enterprise networks. Good. And I think we as IT professionals, we have to adapt to changing times. And there are different things what we need to do. First of all, assurance. I mean, we have to see what are the mission critical applications. It's not Netflix watching in the office. It's something which is really business critical network services which have to be absolutely available, reliable, and measurable. The next thing is basically insights. I mean, up is not necessarily good. Okay, you may have connected to the Wi-Fi. I mean, there are typically two problems of Wi-Fi. I cannot connect or Wi-Fi sucks. These are the 2 things which usually my user community in my home tells me. Or the last thing what he tells me, Uwe, you have killed the internet. That's the ultimate thing. Anyway, there are a lot of criteria, and I will talk a little bit about that in my next slides, what insight means. Automation. If you think about automation, machines should configure machines. I think that's the ultimate ratio of Google. When you talk to Google operations, don't touch anything. It should be done either with an API or with a machine, and that's it. And last but not least, integration to have an experience from client to cloud, end to end. Basically, when we talk about AI operations, we have 3.5 or 4 different stages. Day 0, of course, we have to think about what are we doing in planning of design. Day 1, how do we onboard the equipment? It should be basically without manual intervention, full stack onboarding with ZTP, configuration templating. We have an example, and I will mention that there's a university in the US, which is one of the bigger Juniper customers. Usually, when we saw that the students are coming back, they were having a refresh of the Wi-Fi technology, and it took them usually a couple of weeks to do the upgrade of Wi-Fi. And with that, with our solution, they took them down to a couple of days only to get the full stuff done. Day 2, that's a little bit about when the network is up and running, how can I operate it in a very sophisticated way? How can I make sure that I have the necessary support to fix problems before they occur? And last but not least, we call it day 2+, is the user experience. I mentioned, network up is not necessarily good. So what insights do we have in terms of applications? A good example is, which we will announce today, the integration of Zoom. How can we measure end-to-end if a Zoom call was good or not? You know, and what actions to remediate are we taking? And that's a paradigm shift what we did with Juniper from the beginning 7 years ago. We don't want to manage boxes, we want to manage client to cloud. And when we talk about client to cloud, we talk about users' IoT devices on one end of the slide, connecting to an access point, access points going into the campus network, a number of switches, and last but not least, with the SD-WAN interface to cloud applications, which can be different kind, Microsoft 365, Teams, etc. And that's something we believe makes much more sense instead of looking on individual boxes, because an individual box will not tell you necessarily where is the problem in between from A to Z. We can try when the ultimate goal of, let's say, artificial intelligence is to come to self-driving networks. I don't want to scare you that you lose or that we are losing our job, but at the end of the day, that's the ultimate goal. And I mean, I'm comparing that here with a car driving. I grew up in East Germany, so I would say the left side is either Dacia or Trabant 1980, and the right side is Tesla, maybe in 3 or 4 years. And there are some steps in between. I mean, it starts with no automation. I have an old timer from 1974 with no electronics. We always say we die like men, so no airbags, nothing on it. Definitely no automation. A little bit of driver assistance, you know, maybe you have cruise control available for almost 20 years. Partial automation, you know, when cameras started, you have auto distance driving, you have road assistance, detection of road signs, and ultimately it goes into the full automation, so basically zero human interaction. First of all, that's a legal question. How much would your legal your law allow that at the moment? I think in Germany it's not allowed. So that means human interaction always needs to be possible. If I compare that, it also goes into the direction of what is the framework of a self-driving network, and I think I have that on the next slide. There are 4 stages. First of all, you need to collect. As more you collect, it's like a vacuum, you know. As more data you collect, as better you can make decisions, as better is your let's say, basis where you take decisions on. The easy way is events, logs, the regular stuff, SNMP, syslog, you name it. The question is where you do it. You don't do it on a device only, you do it per user. You do it per application. And what are you doing with the raw data? Basically, first of all, you put it in a similar format, and then you do some first stuff which I would call aggregate and correlate. Typical thing, you plug an optical interface and 100 VLANs goes down. I think that's a classical correlation and duplicate events. The next thing is you need to do monitoring and baselining. A good example in Germany is if you have a DSL connection in Germany, there is always between 2 and 3 o'clock in the morning, you cut the connection. That goes back to prehistorical times when you had to pay DSL per volume. So basically what they did, they generated a radius account after 24 hours. It's still there. Nobody needs it anymore, but it's still there. Baselining would mean, what is my normal situation? If my DSL, I have a Wi-Fi, I have a missed Wi-Fi at home. If my DSL connection drops every night at 2 to 3 o'clock, it's a regular event. It's nothing which I would call an outage. So that's the baselining. And then you do, let's say, more stuff when it comes to supervised or heuristics about to really find out what are health events or what are incidents, what are real problems. And last but not least, what you do unsupervised with machine learning or deep learning is to do some anomaly detection. I will talk a little bit about that. At the end of the day, when you do some analytics in order to troubleshoot the stuff, you would like to come to a conclusion. You want to come to an idea what you do. First of all, the basic thing is a troubleshooting assistant. That means you have a system which gives the operator some hints. We have a loop on layer 2. We have a bad cable, what to do. We have an access point which is not powered enough with a PoE connection. So these are basically a troubleshooting assistant. Do something, but you as a human, do something. The next thing is basically, okay, there are some actions which are automatically done by the devices themselves. We have an example. For instance, we can do automatic AMA. So the system will automatically detect, I have 3 access points somewhere around, and they don't respond. And I'm doing a firmware reset, I'm doing this, I'm doing that, and then the system decides I'm opening automatically what we call a TEC or JTAG call with Juniper, and they say, okay, you know what? Send an RMA straight to the location of the customer. And ultimately, it goes into the direction, no manual intervention required, like with the Tesla in 3 years. So the self-driving network, that's the ultimate goal where we want to be. If you think about, some people ask me, and that's a fair question. I mean, our systems are cloud-based, right? Well, you can have controllers. Do you really think you can do this sophisticated thing with a controller on site? Think about that, and I will show you a picture how an entity for the mist management system looks like. It's nothing you do on site, except you have too much money to pay and basically lots of servers around. Okay, we skip that. I mentioned that AI operations is a journey. If you start today, there's nothing, because you don't have any data. That journey here in Juniper started 7 years ago. And we are still benefiting from accumulating data. Basically data about behaving of networks, behaving of users, in order to understand, okay, what basically, and then you build a kind of timeline, and you build primitives. And then you say, okay, what are the data, how do I put them into specific formats? And then you come up with a data science toolbox. Well, I'm not a big fan of how you call it, dashboards. It might be useful, but ultimately, What I believe makes more sense is to have that kind of stuff. The conversational assistant. I don't know how many of you have been in the presentation for my colleague Slavomir. So it's, what we have is basically a system which is called Marvis, where you can talk to the management system with your own language. And I will show you an example on the next page what I mean with that. So you don't have to think about any CLI command, you don't have to think about any, how do I figure that out? You speak with your own language and you even tolerate, let's say, typos. Because it tries to understand what you're doing. And then, but not least, you take actions on it. There are three components of this Marvis, basically. There's an action framework. That means you have incoming events. And how do you act on that? What actions are you taking with the framework? The second thing is the user experience, because at the end of the day, it's a continuous learning. Continuous learning comes from different things. First of all, you see how, for instance, specific applications are experienced, because that's a user experience. How good was my Zoom call? How good was my Office 365 connection? How good was my video call? And that feeds into the components of Marvis. And last but not least, from the direction from Marvis to the end user, there's a conversational interface where you say, okay, what recommendations do I give to you in order to troubleshoot the network? There are different components, and I try to be, let's say, as understandable as possible. I mentioned there are a lot of, well, how should I call it, misunderstandings. People let's say, okay, machine learning is artificial intelligence, or deep learning is machine learning. Different things. Deep learning is basically a category of machine learning, while, let's say, artificial intelligence is the overarching definition. There are different methods in how we basically do the different things. Machine learning, for instance. Good example, Bayesian interference. I don't know how many of you have a mathematics background. It's a lot of the statistics. So basically the AI team is a bunch of mathematicians in Juniper networks. The Bayesian interference is basically, you have a hypothesis, how the statistics could look like, and with following events, you adjust the hypothesis when it comes to, specifically here, when you think about, we have a function which is called auto placement of access points. You have an idea where the access point should be, but maybe, let's say your coverage, your user experience will tell you, you have to adjust that. What else do we have? Specific online ARIMA, we will replace that with a better algorithm. Online ARIMA basically means a time series anomaly. Over a long period of time, I try to understand what is an anomaly. What is a broadcast storm? Or what is let's say, what is a non-responding port? Is it 5 seconds? Is it 10 minutes? So you try to figure out what anomaly is. And I think the DSL connection drop in the night is a good example for that. Good. How are we with the time? I think we are looking good. So you see here, as I mentioned, Shapely. Shapely is a statistics function coming from the gaming theory. Basically, you can say there are a number of parameters who are influencing a specific event or a specific decision. In the gaming theory, you may say, okay, if a different gamer is joining my team, how much does he contribute and how much do we gain? That's the fundamentals of the background of the Shapely value. And basically what you do here is you say, okay, how many of specific parameters have the majority of impact on a specific thing? Where are the screws I need to turn? Reinforcement learning, I think that's very easy to understand. Radio resource management. How do I deal with the channels? How do I deal with interference between different access points? That's a typical example of a reinforcement learning. Good. AI operations is teamwork. And AI operations is not only, let's say, a part or the work of the MIST data science team. Yes, they play an important role on that. But there's also the MIST customer success, the customer support team, because we also learn from that. We learn from specific, let's say, failures, specific situations where we can say, okay, we feed that into our knowledge base. And last but not least, our customers. Because we also learn from the customer experience. And we learn a lot from the customer experience because at the end of the day, we want to have a good customer experience ensured. And that's where we learn from. And if it's bad, we learn from it even more. This is a picture of the MIST microservice architecture. So this is how an entity in an AWS cloud in Frankfurt looks like. We have a cloud in Frankfurt for GDPR reasons. We have a cloud entity in US. We have in Asia Pac. We have a federal cloud. So we have different cloud entities around the world, either based on AWS or on Google. And that's what you can see. It's quite a complex system, a microservice architecture. Why a microservice architecture? First of all, it scales very well. You can easily shift from one entity, from one cloud entity to another entity, and you can easily add new features. When you look at feature velocity, what we have, you don't have to update any controller. Basically, every 2, 3 weeks, 4 weeks, we're getting new features rolled out across the entire cloud architecture. Everything what we do in our systems can be done with the API. That's also sometimes very important. I mentioned Google, machine configure machines, and literally all features, not literally, all features what we're having on the graphical interface are also possible via an API. I have a team member, he's something quite good on APIs, so what he did is basically he wrote a little application in order to control the access of the internet for his kids. So basically what he said is, hey Siri, switch off the Wi-Fi. And basically with a MIST API, he's switching off the Wi-Fi access points in the kids' room. So quite a cool stuff. All right. As I mentioned, we talk about client to cloud. We talk about, at the end of the day, we want to know for the client why my call is breaking up, as an example. And you can have a look, basically, on 3 different parts. The Wi-Fi assurance, what is going on in my Wi-Fi network? Do I have the right connection? Do I have the right coverage? Do I have a sticky client? Do I have radio interference? That's a good place where you have the Wi-Fi assurance. The wired assurance takes care about the campus wired LAN. It can be a small branch offices, it can be a very complex campus enterprise infrastructure, switching infrastructure can be based on eVPN, VXLAN. And last but not least, what about the gateway to the wide area networking? Do we have the right quality of service there? Do we are having the right treatment of specific applications? And that's all is controlled then basically on a graphical user face, or if you want, on the conversational interface of Marvis. If you ask us what is, I mean, a lot of people today talk about AI operations. As I said, we started 7 years ago, and the question is, what separates us from the other parts? First of all, we have measurable user experiences. We measure every end device. We know what's going on every end device, if it is an iOS, an Apple phone, if it is an IoT device, if it is a device connected to a switch. Every minute, every user, we have the information, 115 parameters which are measured from every single user in the network. And the user, as I said, can be different. Can be an IoT device, can be an application. And what we have is the integration under a single AI engine. So you don't have three different screens. You have one screen which is for the local area networking, for the Wi-Fi, for security, for the wide area networking. What is super important if you want to have a reliable anomaly detection is you have to have a good per site basis. So that's the most important thing. What is my normal situation? And your normal situation is better as defined as more data you have. And that has been proven over the last 4 years on a per site basis that we have very good database in order to have a good baselining. Another example, AI-driven support. Support tickets can be opened automatically without any intervention. These are some examples which we believe differentiates us from some of our competitors. What we are doing, basically we are measuring specific parameters which are representing user experience. And that can be, for instance, the time to connect. How much time do I need, or do devices need to connect to the network? What is the throughput? How many successful connects do I have? How is the roaming? And what is the uptime of the access point? Sounds interesting. We are not interested in the 98% or in the 71%. We are more interested here on that side. Why do we don't have 100%? So why do we have, let's say, for instance, the coverage problem, 3% coverage problem? And you see here, we have 99% of those problems are caused by a weak signal. And then you can zoom in and you can basically see, okay, what is the reason, the root cause of that problem. And what you can do is, on a per site, you can set your own service level entities. You can set your own service level parameters. For instance, you can say, okay, time to connect, within 2 seconds I want to be connected, I want all devices to be connected to the network. And that's basically a very easy way to customize your service level agreements. One of the things, basically what we are introducing, broadcast storms on wired networks, is a problem. I was mentioning ARIMA. We started with an average. Basically, when you do a baseline, you say, okay, what is the average traffic you have on a specific interface, on a specific time? And what we are doing is basically we develop what's called LSTM model. It again comes from the statistics, mathematics, to take specific data on a specific time of the day. Okay, how you define a broadcast storm? There might be very, very different definitions depending on what kind of part of the network you're looking at. So what you're looking is, what time of a day I have, how many drop packets do I have, how many unicast packets I'm receiving and transmitting, how many broadcast and multicast packets do I have. And then you basically do a modeling and you say, okay, what is my lower confidence, what is my upper confidence, and where is the mean value which I believe defines the broadcast storm. The model is trained on a per site basis. A site can be, let's say, a part of your organization. It can be a small part of a campus. It can be, let's say, a whole city. And then you say, okay, per site, I'm training this model twice per week in order to get a better understanding and a better data modeling. Every 30 minutes, Marvis is checking for anomalies. Do I have anomalies based on that model against the the average value. And then basically you adjust the model twice per week according to the measurements. The other thing is, when do I find out that a port is stuck? Again, might be very, what do we want to do? We want to find devices where, let's say, the traffic has gone to 0 or has dramatically dropped. But again, sometimes a specific drop of traffic can be absolutely normal because you have your PC and you go at home and you switch it off. Is that an anomaly? No. So you've tried to build a pattern where you say, okay, this is a camera, this is a surveillance camera. So I'm expecting regular transfer of data, of video data. That is a point of sales terminal. I have a different traffic pattern. But I know, let's say, from 8 in the morning when the shop is open to 10 in the evening when the shop is closing, at least I have 2-3 transactions per day. So I cannot say this is a stuck port if there's, let's say, for 1 hour no traffic. So basically what we are doing is we are, again, building a baseline which is based on the traffic of the last 7 days. For the last week, we are trying to figure out, okay, what could be a normalized thing. And we have basically, for every port, every 20 minutes, we are building a kind of modeling. What we say is basically, take a function of the average transfer packets and receive packets for the same time for the last 7 days. There might be a difference between the weekend and the week, as a good example. The next thing is we have templates, we have similar sites. We have similar sites and same device types. So we know, for instance, at this port, there's a point of sales terminal connected bus, and we are comparing it with same sites and same device types. And then basically we say, okay, what is the duration in the suspected mode? I was mentioning the point of sales terminal. You may have no transaction, you may not have a traffic for 50 minutes or for 1 hour. Could be something. If there is no video signal from a surveillance camera for 2 minutes, that's a different story. So basically these are the parameters you take into consideration. And last but not least, you build this regression model and you say, okay, what is the action? Do I have to take action? Perhaps I don't have to take action. So that's something we are doing without any user intervention. So there's no operator, that's all done automatically. And last but not least, the similar thing goes for high CPU. I mean, what is a high CPU? Sometimes you have spikes in your regular day. So you take the CPU data from a switch, you calculate you do the calculation on the statistics for the CPU, and basically again you do it, let's say, with the mean, with the median, 75%, 90%, and then you have peaks above. And then you say, okay, what action can I do? Do I kill specific processes on the switch? Do I switch off ports? These are the things which are, again, can be based and decided on a, let's say, side-by-side definition. I'm running out of time, I know, so maybe I have to skip some of the slides. The conversational interface. This is something what you type in. Can you read it? Basically what I type in is, what is wrong with live demo? Live demo is a site name. And that's the only thing what you type in. It can be also, what is wrong with site Brasov? Or what is wrong with campus building 1? Marvis understands, okay, and he converts it into, let's say, the machine code, which is called, or the language, which is called troubleshoot live demo during last 7 days. So you don't have to know the syntax, you just type in, show me all unhappy users. And he also will translate that. And basically what you do is he said, okay, the answer is we found 3 service level problems. AP uptime, 90% of the time the access points were up. Not good. An access point should be up 100%. Coverage, we had poor coverage, wireless coverage. Because there was a weak signal. So there might be, and here's the name of an access point, which may have a problem. And last but not least, there were unsuccessful connects, 77. And then basically, he comes up with recommendations. He said, okay, you do this, and you, by the way, I will replace this access point with an RMA, with an exchange, automatic exchange request. That's how it looks like. Basically, what MIST is doing, AI is doing, is he sends out an automatic email. He sends an email, hope you are doing good, reaching out to you because I did a proactive health scan and we found 3 access points of the organization where the radio health check has failed. That's not operator, that's basically the AI-driven system, and then they tell, okay, these are the access points, MAC address, blah, blah, blah. So as a proactive care, I tried everything, I reset the access point, I upgraded the firmware, I checked if everything configuration is good. I will RMA, basically here we go, and we ship it out. No interaction needed. Sounds good, huh? That's inside Juniper. Basically, it gets, it's your organization. It's from a client, and it goes to the client, and as well it goes to the Juniper organization, and we know about that we have to ship 3 new access points. Okay, the other thing what we are doing now is we integrate ChatGPT in a way that we are integrating all that we have called as a knowledge base about existing tips and tricks, known problems, as well as all the Juniper manuals and documentations, and we make that available via ChatGPT. So basically there will be a new feature we're saying, show me how to configure an EX port for VLAN. And then it shows the relevant part of the documentation. I mean, at the end of the day, I mean, I'm born in 1963, so I still like that movie, you know. So we want to do the following. The network engineer, Mr. Zulu, or whoever it is, how are you today, dear network? And the network is answering, not too bad, we had a few more radios failures than normal. So that's the ultimate goal where we want to go. And with that, and my favorite movie, I think I have reached the 45 minutes, and as a good German, I want to be on time. Thank you very much. Mulțumesc.